Now let's learn how to solve 3 by 3 Rubik's Cube. Before we start learning how to solve the cube, we need to know the algorithm notations which we will be using. So the side that faces you will be the front side. This will be the top side. This is the down, right, left and the back. So if I were to say front, you need to turn the front side of the cube 90 degrees clockwise, like that. Similarly, this would be front inverted. This is right inverted. Note that right is like that and left will be the opposite of that, because when we say right, we refer to it as though the clock will be turning on that face. So this would be right and this will be left. Similarly, this is up, down, up inverted, down inverted, and back inverted. So now that we know the algorithm notations, let's go ahead and jumble the cube. Okay, so now the cube is all scrambled. Whenever we're referring to a piece, we will take the reference as the center, because the color of the center determines the color of the side. You can't really turn the center and you can't switch about the positions of the center. The interior of the cube is like that and you can't really switch the positions of the center. So let's go through some basic algorithms that we'll be doing while solving the cube. The first algorithm is a very important algorithm while solving the cube, and the second one is nothing but the reverse of the first algorithm. So if I say right inverted, down inverted, right down, and if I do the second algorithm down inverted, down right, I'm actually just reversing the steps that I just did. Sometimes we notice that using the reverse of the algorithm will be quite faster than using the algorithm itself. So let's begin solving the cube. Let's begin with the green side. So now I have the green center. So this side over here must be the green side. The first step I'll be doing is solving the green plus. This is the green and this is the orange center. So the piece over here must be the green and the orange piece. Let's search for it. And it's over here. So this piece, first what I'll be doing, I'll connect the orange with the orange. So this orange is over here and I should connect this one with this orange over here. So by doing that, I can connect it. Now by turning this face, I can connect this green piece with that one, just like that. So now I have green and the white. Let's search for the piece. It's over here. So now when I try connecting the piece, I notice that I'm unable to connect the white with the white piece. So in such a situation, I'll bring the piece to its position and perform the following algorithm, keeping the white as the front face and the green as the top face. So the algorithm is front inverted, up, left inverted, up inverted. So we notice that the piece has been switched and it's now in its correct orientation. But now let's take a moment and look why the algorithm works for the following situation. So what we are trying to do over here is connect the green part of this piece to the green so that it's flipped correctly. So when I try doing that, I'll be successful in connecting the green. However, I'll be ruining the position of the other other parts of the plus sign I've done. So when I do the turn the up face, it will not be spoiling the other parts of the plus, because I will turn back it while putting back this piece over here. So now let me do green and the red, which is over here. So now I can see that instead of doing that, I can directly connect it like that, to get the red with the red, and then I can do the green with the green. So last piece I have green and the yellow, which is over here. So I can flip it out using the same algorithm, front inverted up, left inverted, up inverted. So now we have the green plus ready, and we need to do these 4 corner pieces right now. So let's do green, red and white. So this piece over here has to be the green, red and the white piece, and the piece is over here. So now let's bring it below the position where it needs to be. So it needs to go up here, so I've brought it below the place where it needs to be. And I'll perform the following algorithm which I just showed you. Right inverted, down inverted, right down. I'll repeat the algorithm until the piece comes into its correct position. However, we can notice that in some situations using the reverse of the algorithm will be better. As in this situation, I have green, orange and yellow and the piece is over here. So now I can use the reverse of the algorithm as well to get the piece up over here. So that will be down inverted, right inverted, down right, down inverted, right inverted, down right, down inverted, right inverted, down right. So in other words, if the piece which I am trying to put up, the green color is facing me, when I keep it in the right hand side, I can use the reverse of the algorithm like that. However, if it's not facing me, when I've kept it, when I kept the piece in the bottom right, so I can use the first algorithm, right inverted, right down. This is just to reduce the time that we take while solving the cube. Sometimes we can notice that the piece which we are searching for is already sitting in another place over here, which is the incorrect position for this. This piece over here needs to go over here. So I can use the same algorithm to bring this piece down and then get it below where it needs to be and then bring it up the normal way. So I'll do right inverted, right down, and notice that this piece has come down. Then I can bring this down below where it needs to go and then with the help of the same algorithm bring it up. So now I have the first side of the cube complete. At this point, we would have completed one side of our Rubik's cube. So now let's flip over the cube such that the side that is completed is on the down. So now we'll go ahead and complete the second layer. When we have completed one side of our cube, it's also essential that we would have completed one whole layer. So now we'll go ahead and solve the second layer. So in help of two algorithms, we'll be able to solve the second layer. So now let's go ahead and solve it. This is the red center and this is the yellow center. So this piece over here needs to be the red and the yellow piece, which is right over here. So I can notice that the red piece is on the front side. So I'll get the red to connect with the red center over here. So now this piece has to go to the right. So I'll apply this formula: up, right, up inverted, right inverted, up inverted, up, front. So now we can see that this piece over here has come to the right hand side. What this actually does is that it brings this piece over here to join with this piece over here and then flips both the pieces together. So I'll just do that algorithm once more real quick. Yes, so now let's do the algorithm once more. You can notice that this piece is coming up and joining with that piece. Up, right, up inverted, right inverted. So we have connected this piece and now we are going to get both of these to come over here together. Up inverted, up, front. So now we have that piece over there. So next let us put the white and the red, which is right over here. So again be sending this to the right hand side. So I'll be doing up, right, up inverted, right inverted, up inverted, up, front, and there we have that piece. So now let's do yellow and orange. Now I notice that the top layer does not have yellow and orange which I am looking for. It has been embedded over here. So I need to take out this piece. To take out this piece, I'll be putting another piece in its place so that this will come out and then I can put this piece in its correct location. So now I can put this piece on the left hand side to remove this. So the left algorithm will be up inverted, up, left, up, front, up inverted, front inverted. So now I can see this piece has come out. So now I can connect the orange with the orange and I can see the yellow has to go to the left hand side. So I repeat the same algorithm: up inverted, up, left, up, front, up inverted, front inverted. Even in the left side algorithm, this same procedure is getting repeated. The corner piece is pushed up to connect with the edge piece and both of them are flipped together. So let's do the last one, which is over here: up, right, up inverted, up inverted, front, up, front. And now we have completed 2 layers of our Rubik's Cube. So now while solving the last layer, there are many permutation combinations that can occur. So now there are 4 possibilities that can occur while we solve the Rubik's Cube. One is we get the blue dot. Second is we get a backward L. Third is we get a horizontal line or the plus. So right now we are aiming to complete the entire blue plus. So when I have a dot over here, I'll perform the following algorithm: front, right, up, right inverted, up inverted, front inverted. So now I get a backward L. So I'll perform the same algorithm to get a horizontal line. And when I repeat the same algorithm again, I'll complete the top plus. So now I need to be solving these 4 pieces on the Rubik's Cube. Now at this stage, I find that all the 4 pieces are solved. However, there are many situations when all of them are not solved. Yes. So now in this situation, I have 2 pieces that are solved which are opposite to each other. Note that in any position you will have at least 2 pieces that are solved. You just need to turn the top layer to find out which 2 pieces are solved. In this case, I have a yellow and white edges that are connected and are solved. And now I aim for solving all 4 of them. So I'll keep one in the front and one at the back and perform the following algorithm: right, up, right inverted, up, right, up, right inverted. Now the 2 solved pieces are next to each other. So I'll keep one at the right hand side, one at the back, and perform the same algorithm: right, up, right, and one final up to complete all the 4. Now we need to do the last 4 corners of our cube. So usually we'll have one corner that is in the correct position, as over here, blue, white and red, and blue, white and red. In case if we do not have any corner, it's fine. We'll just perform the same algorithm, which I'll tell you in a minute, to get to one corner that is in its correct place. So now I have one corner in its correct place. I keep it in the bottom right hand side and perform the following algorithm: up, right, up inverted, left inverted, up, right inverted, up inverted, left. So now after performing this algorithm once or twice, all the 4 corners of the cube must be in its correct position. So now if I flip these 4 corners, I'll be done with solving the Rubik's Cube. So I'll perform the same algorithm which I used while solving the first layer: right inverted, down inverted, right down, till the piece is flipped. Now I'll get another piece in position and continue to flip. At this time, it might seem as though the cube is getting spoiled. However, when you're done with flipping all the corners, the cube will always be solved. And now one last turn, and we're done.